Yep, zoom
So it's not really, let's see.
a bash shell in the browser. And so the different actions interact with each of these. So we have the IPython run cell action, which runs something in the IPython server. We have a command run action, which runs a bash shell, and we have a browser thing that works in here. And this figure is a little bit old. It's working? Okay,
Yeah, it's working.
Great. This figure is a little bit old. We have a few additional things that we're adding in. We are adding in, we've added in a way to like kind of compress the agent's history so that you don't have to feed in like lots and lots of tokens into the output. So we have a summary action, and because MCP is all the rage nowadays, we're thinking about doing something special for MCP, but haven't quite finished yet. But this is a basic idea. So when you're working with coding agents, you'd like them to do a variety of things, but at the same time, you don't want them to like RF your home directory. If you played around with Claude, you will know it gets very enthusiastic about solving its tasks, and that might involve removing all the files in your home directories. So the way we've handled this is like all of the things run in a Docker sandbox where it's isolated away from your system, and you don't need to worry about it deleting things or getting access to things it shouldn't be getting access to and stuff. And I mentioned about the actions, so I'll just go through them quickly. We have a terminal where you can run commands, and a Jupyter Notebook where you can run Jupyter things. We also have a web environment, and this has gone through a few iterations. We use something called BrowserGym, which is like a web agent framework, and it can browse various things. One thing that Xingyao just added, which is kind of cool, is now the browser can view like PDFs or web pages or things like this visually. And so he actually used it to fix a paper that he's writing about some of the research that he's doing later, and had it compile it to PDF, viewed through the browser, and like refine the layout and stuff like that. So these are kind of like interesting things that you can do if you give the model the ability to code and the ability to see like visual contexts and things. So the code editor, I asked OpenHands to make a more beautiful figure of this, but I forgot to copy and paste it into the presentation. So sorry, this is very ugly. But basically, we have a file editor. This file editor is very similar to the file editor that was kind of created by Claude. And basically, what it can do is it can open files and read like lines in files. It can replace segments of files. It can append to the end of files. It can also undo its like file editing actions and things like that. So this is really important. If you're building an agent on a language model, we actually encountered a huge number of problems with like file editing not working very well about 4 to 6 months ago. But now a lot of the models have been trained for file editing, so they do this a lot better. Cool. And then we have things for the interface. Should I? Yeah, okay. Cool. So like another thing that we're thinking about a lot, and actually we love feedback on, is how we can interface with agents. And right now, our visual user interface has a chat window. It has a window where you can view the web browser. You can view the Jupyter Notebook and the terminal and things like this. But there's a lot of refinement that could go into this. And if there are things that people like or don't like, we'd love to hear them from people who've used OpenHands before. But another thing that we're excited about is I think that development is going to move beyond like the IDE, and it's going to move into all of the places that we do communication. And so we do communication on GitHub. So we have a GitHub integration. A lot of people use GitLab, so we recently have built a GitLab integration so it can interface with that there. We have a way to send things from Slack. And other things like that. I'm also like, I use it on my phone all the time with speech recognition. So now we can, code with our voice and other things like that. So there's lots of different ways you can interface. Cool, agents. Do you want me? Okay. Sorry, I'm trying to hand it off, but they won't let me. So in terms of how agents are implemented, basically we have a step function, and the step function takes in the current state of the world according to the event stream, and decides the next actions that you should be taking. And as I mentioned, like when we first started out, we were thinking of making this like a multi-agent framework where you could implement lots of different specialized agents and stuff like this. But eventually what we settled on was we have the Kodact agent, and the Kodact agent is something that was created by Xingyao kind of as a research project. And the way it works is you basically take most of your actions in code. So instead of creating a whole bunch of different tools for the model to use, you basically have it write Python programs, and you give it access to the libraries it wants to use as Python programs. But one way that we have been not necessarily creating a multi-agent framework, but trying to make a single agent that can become versatile is by using something we're currently calling micro agents, but we are debating about whether we should rename it or keep it that way, is we basically have these prompts where the prompts are either information about kind of like your repo and your repo conventions. And we can also have kind of like task level micro agents that you can go in and use to say, okay, this is the appropriate way to interact with GitHub. Like, don't try to browse to the GitHub site. Instead, use the GitHub API. When you open a pull request, never push directly to main because the agents used to do that. Let's see. Open draft pull requests instead of like regular pull requests. Yeah, actually, I can mention a little bit about that too. Like one of the experiences we've had is like, how do we deal with agents that are like doing a very large amount of our development work? One of the problems was we would like invoke our agents, and it would open a pull request. The pull request would be from OpenHands agent, and then it would sit on our repo, and like nobody would review it. We would get a whole bunch of repo spam from like pull requests and stuff like this. And so we made a few like small changes that really help. Number one, now pull requests get sent as the person who invoked the agent. So basically, like if I invoke the agent, it's my responsibility and it goes in my name. And so that's kind of important. Another thing is, I think that's the biggest one. Yeah, oh yeah, and it's a draft. So you can tell that it's not actually been checked by a human. And then when it gets checked by the human who invoked the agent, then you turn it into like a non-draft and you get somebody else to check it for you and things like that. So like these tiny things have made it like a much better development experience when developing with agents. Cool. Sorry, I'm talking a lot. Are there any things that people, yeah?
What's the sort of hardest thing you've built internally or any project that you know of?
Yeah, I mean, an agent that does coding. So no, but seriously, the hardest thing we built with it is OpenHands, because OpenHands is a pretty complex framework. It uses Docker, it has a backend, it has a moderately complex front end. I know there's a lot of other people who have like used it to build, relatively complex web apps and stuff like this. Another thing that Xingyao, community members in Xingyao and I built recently is a visualizer for trajectories. So I don't know if we have this live.
Yeah, we have it.
Yeah, could you type that in? But basically, we were having trouble debugging our agent trajectories, so we made. And I don't think we have files, but yeah, we made a trajectory.
Yeah, I have a screenshot somewhere.
Okay. Yeah, we were having trouble debugging our agents, and we wanted a way to do this, and so we.
Yeah, we got something like this.
Yeah, so it made this this thing for kind of debugging agent trajectories, and like on the left we have like how much did it cost to solve each thing? Was it resolved or not? This is on a benchmark called SweetBench that a lot of people might have heard of. And then we have all of the actions and things like that. And you can browse through and look at things. So
Yeah.
this took maybe
half a day.
half a day.
Basically,
make something.
between meetings, I was like, I got message from the agent. I look at it. Oh, no, you should put the button there. It's like I'm basically playing the role of like a product manager.
Yeah.
rather than-
So there's a fair amount of stuff. Yeah.
Back in your micro agents
Yeah.
comment, could you be a little bit more specific about what you think of as like a micro agent versus a more general agent? Is it just that it has a specific tool, or
Yeah. So this is a good question. This is a specific prompt at the moment. So the tools actually aren't changing, but like up until very recently, we've been basically like relying on the fact that language models know Python, and Python implements a whole lot of things. There's a whole bunch of libraries that you can use through Python. So if you just tell it the right library to use, and the canonical way of doing it, it can kind of like solve a lot of tasks. Now with MCP, I think we probably will also want ones that are like, okay, you have a prompt about how to use this MCP thing properly, because just because you get an MCP like tool doesn't necessarily mean that the agent will be able to use it effectively. So I'm thinking that we might also add micro agents that like interface with MCP servers, for instance. Yeah.
would the planning agent would the planning agent be selecting which micro agents to invoke as part of its like tools, or
Yeah, so how micro agents are invoked right now is if the user mentions a specific keyword, it gets invoked. So like if the user says GitHub, it will automatically get invoked. And that's actually pretty good for like users who aren't very familiar with things. That's probably a little bit like, I don't know, it's coarse. Like they could say Git and they actually not be talking about GitHub or something, but that's what we do that. Yeah.
This is what OpenAI does, though. They also do the keyword approach.
Yeah.
So,
Cool.
So they're like for coding tools like Cursor or all other tools, I think they market in a way that right now Cursor is running itself. So do you have internal statistic of how many PRs or code is written by OpenHand itself on OpenHand?
You have that?
Yeah.
Let me
So
just put out the repo.
yeah, let's go to the repo.
One of our engineers was recently complaining that he was surpassed by OpenHands as a core contributor to the app. So
Yeah. So our number one is Dependabot. Number 2 is Xingyao. Number 3 is Robert. Number 4 is one of our open source contributors, and number 5 is OpenHands agent.
This is like all time.
And that's all time. And then if you go for the last 3 months, it's the number 1 contributor to our repo. Yeah. Yeah. And
the ratio of open like merge PR versus close PR?
that's a good question.
yeah, I mean, sorry, I need to repeat the questions for the people in the back. Sorry about that. Yeah. So the question was, what are the number of merged PRs versus closed PRs? I think we actually had a monitor that was monitoring that, but it recently got out of date and I haven't updated it yet. But I think a lot of it depends on like how hard you're going to work to merge that PR. Because it's pretty easy to go in and like fix a PR that isn't good unless it's completely off base. But often we do like a fair amount of iteration like with the agent before the PR actually gets merged. Yeah.
Okay, could you go back to the micro agents?
Yes.
I have another question about the knowledge. We know it triggered the keywords, right?
Mhm.
So do you have any plan, like if I have a lot of knowledge, like some like random task can trigger lots of keywords. Do you have a plan to have like advanced search or something like that to find the correct knowledge better?
So-
Yeah, go ahead.
So we actually just changed this, like, we pushed the keyword matching through a new, what we call the recall action for the agent. And so now the agent, it's kind of part of the event stream now. And so it's kind of the first pass towards RAG, right? So that recall action and observation can potentially, as we build it out, extend to other systems. So we could hook it up to Jira, pick it up to NCP, we could hook it up to an existing knowledge base and let the agent search through that. And the agent can decide, okay, now I want to go search through Jira for X to see if there was a previous issue for this. But that's I would say we're kind of setting ourselves up for that. Right now, it's all just keyword.
So is this?
Hold on.
When you say the MCP, is this a client or a server in MCP? Like you will be able to invoke the MCP servers.
Correct. Yeah, we would be a client. Yeah.
You will be a client, right?
Yeah.
So another question that I have is when you have a stream of events that you generate when I ask for a specific prompt, is there a way, like if there is an ambiguity that it could stop and ask the user that there is an ambiguity and like would you help me here, and then continue again from the same point, like because you're anyway using the state, right? So is that something like that that you can do?
So it's a great question. It's probably one of the biggest issues with using agents these days is that large language models are very eager to help you. And so they will just plow through ambiguity and be like, I think they mean this, and just start off and running, right? Xingyao has actually been working on what he calls a critic model, which can take a look at basically what the user's prompt was and the trajectory that the agent is taking and can decide, is this going in a good direction or a totally bad direction? And the idea is that we can basically flip a switch where if the critic says, hey, things aren't looking good right now, it'll stop the agent and we can either ask the user for more input or the critic can send info back to the agent saying like, hey, you should stop doing X and do Y. But it gives us kind of like a switch that we can flip to stop the agent in its tracks before it like does armed RF on the home directory.
So how well does two different models work on like feedback? Say in a PR, if it comes up with a solution, but it's like incorrect, how well does it respond to user feedback? Is there like a model-based comparison? You have like Claude, Gemini, OpenHand.
Do we have a
we have an evaluation section.
Yeah, but not. This is about like feedback on PRs, right?
Okay.
Yeah, I don't think I don't know of any like rigorous benchmarking about like, okay, you have a PR, it's like you have a PR and you got feedback from a like review feedback. Can you go and like accurately reflect that feedback? There is an interesting benchmark that just came out from JetBrains on fixing merge conflicts that we're like evaluating on now. But we just started with that. And so we don't have like a model by model comparison or something. Yeah.
Okay. So thanks for the presentation. I have a problem about the context length issue, because I think the biggest advantage of using agentic to solve problem is it allows us to solve the problem by multiple turns with the LM. But currently, if the term, if the context is very long, how do you do the truncation? Because currently, I know you will have a truncation mechanism. You will take the first turn and then half the rest. I think that's your current solution. So I just wonder, because I think you mentioned you will do some summarization. So when to trigger such mechanism? Yeah, that's my first question.
Yeah, it's a great question. This one we actually do have an evaluation of, but we haven't like published it publicly yet. The code's in our code base, but we haven't like written a blog about it or anything. But basically, we tried a whole bunch of different strategies, and there's two things you need to think about. Like number one, how good is the strategy? And number two, how efficient is it, including considering prompt caching? Because prompt caching, if you keep the same prefix of a prompt, it becomes much, much cheaper for like models like Anthropic or Gemini or other things like that. So eventually what we settled on is you summarize every n steps down to n divided by 2 steps. So like if n is equal to 20, then you would summarize every 20 steps and reduce down to the previous 10 steps, and then a summary of the further previous 10 steps. And that summary is generated by an LM to keep the most important information. So Yeah, it's a little hard without like a whiteboard to explain exactly what it's like, but that was the one that gave us like good scores on Sweetbench and also was like effective with prompt caching and cheap and things like that.
Okay, thanks for your explanation. Yeah, when you say it helped you to get a good score in a Sweetbench, so my second question, also the last question, is about how when you report the score, do you just take the average of the resolution rate, or because when we use the agent together with AM, we usually do not set the temperature to be 0. We will make it the temperature to be 1. So we will get different score over different runs. So what to make the resolution rate to be more reasonable to us? Yeah, because take the best or take the average, because it differs according to the experimental results.
Yeah, I'll maybe talk about that in a little bit, like with our evaluation part.
Okay, yeah, thanks.
I wanted to understand, how do you keep the PRs to be small enough that they're reviewable? Like if they become too big, they become too useless.
Yeah.
Cannot review them. So what do you do to make sure that the PRs are small?
Yeah.
I mean, it's similar to how you would do it with a regular development team, right? Like, there's nothing stopping a developer from putting up a gigantic PR. You can definitely prompt OpenHands into a giant PR. So it's more of like a best practice in how you use it. I have put together very large PRs with OpenHands where it's like, this is a thing that just all needs to, like, it's a refactor that needs to be done all at once. And there's actually some of my favorite tasks for OpenHands have been very large PRs where I don't want to go in and edit 50 files to change the name of this function or to change, like, I'm going to switch. I did one over the weekend trying to get rid of Redux from our code base and switch it all over to a different state management system. And that involves, I think there's 80 files in the PR that are edited. It's all boilerplate edits, right? You can kind of eyeball that it's the same edit to 20 different files. But it was so much nicer to do it with OpenHands than to do it all by hand. Yeah.
Yeah, so my question is, like, since there are so many moving parts in this area, like tools, specialized prompts, model, and the orchestration which decides the next step, right? Which part gives the biggest accuracy jump based on your experiments in terms of, like, like you also mentioned, like you're doing a compaction and by do, and now the micro agents is the iteration of the prompts. So which part is like gives the biggest step jump in your benchmarks, and also, like, in the future, which part do you think you're going to focus a lot on, which you think is going to provide the biggest accuracy jumps?
Yeah, it's a hard question. I'm going to talk about like evaluation in a little bit, and I don't think like Sweetbench is like the end all and be all of evaluation. There's so many other things we should be evaluating, but like specifically for Sweetbench, I think it's a little bit tricky to say because we've done so many little things. Like the very obvious thing is you need a good base model to be working with, and like better base models give the biggest jumps, I think. But beyond that, there's a ton of little things that give you like 1% to 2% accuracy each. Like having a really good prompt, asking it to find the relevant context before it starts working is one thing. The editing tools being good editing tools makes a big difference. Asking it to reproduce the bug before it starts makes a little bit of a difference. So yeah, I unfortunately it's been a lot of like little engineering, but that leads to it being, good in the end. Yeah. Yeah.
So you mentioned that you considered multi-agent to start with, but settled on the single agent architecture. Could you elaborate more on the learning?
Yeah, mostly maintainability, I think, and like so there's kind of two things, like maintainability, and also if you come up with a multi-agent architecture, like if you've taken a machine learning class before, there's an idea of like a bias and variance trade-off, and bias is basically like you get the model to really tend to do a single thing. And variance is like how much it can work if it moves outside of that like single thing that it's good at. And I feel like a lot of the multi-agent systems that are very architectured are good at doing that like one thing, but they're not as good when they start doing something else. So just to give an example, there's a lot of things that have reasonably good scores on Sweetbench, but just don't work at all for a lot of the other things you want to do, like downloading documentation and then reading the documentation and implementing something based on the documentation. So the single agent, simple single agent architecture allows you to be more flexible and still get like reasonably good results and stuff. So, thanks for all the questions. Maybe should we go through the evaluation part, because I think that's pretty relevant for
through some questions too.
So we'll go through this, and happy to talk about things other than that later. But so we, as I mentioned, we aim to excel like not only in code editing, but also in like web browsing and other auxiliary tasks, such as answering questions about code or conducting online research. So we actually have a really extensive evaluation framework. So if you're doing any sort of like agent research, it's a pretty good place because it has like all of these benchmarks included. And this is old. This is from our paper. We actually have maybe twice as many now, including software testing and other stuff like this. So that's one thing. For software engineering tasks, we mainly focus on Sweetbench. We've also been working a little bit on something called Commit Zero recently, because Commit Zero is based on like implementing largish repositories from scratch. For web browsing, we have one called Web Arena, and Web Arena basically is doing a bunch of web browsing tasks on like sandbox websites, and so we use that for evaluation of web. And another one we're focusing on is Gaia, and Gaia is like you're given an Excel file and you need to answer questions about the Excel file, and you need to answer questions by doing web search and other stuff like this. So we hadn't really been focusing on this a whole lot, but recently we've been focusing on it a lot more and like iterating and improving our performance at it. This is a bit old. We demonstrated that we're able to do pretty well on all of these, but maybe the more interesting one is this is not the absolute most recent result, which Xingyao is going to talk about, but we evaluated on Sweetbench Verified, and I tried to summarize which language models were the best for coding as of like 3 weeks ago or something. And things change rapidly, but this is for each size class. So Xingyao is going to talk a little bit about SweGym, and SweGym is a training environment that we created for software engineering agents. When I say we, in collaboration with Berkeley, people at UC Berkeley, who are also in the audience, so thank you. So the 7B model that we trained here got about 10% accuracy. And then the 32B model got about 20% accuracy. DeepSeek V3 and R1 got 32 to 34% accuracy within our framework. O1 and O3 got 45 to 47% accuracy. Claude 3.5 got 53. Claude 3.7 got 58. And then we basically took 4 systems, Claude 3.5 and O3 Mini, and we re-ranked them with Xingyao's critic model, and that gave us 61. And as I said, these are like 3 weeks old, and we have somewhat better results now.
What's current state of the art?
Current state of the art on the leaderboard is 64. Yeah. And what they did there was they generated 5 outputs. Five outputs with O1, and then re-ranked with O1 there. So
is that Sean's or?
Yeah, that was Sean's. Yeah. Cool. So yeah, we have 2 announcements that we'd like to make this time. So these are new things that we haven't talked about before. So for one, I'd like to turn it over to Xingyao.
Yeah. Hey everyone, I'm Xingyao here. So today I'll be talking about like the release of like our first version of OpenHands LM. So I'll be talking about how we create training environment, how we actually train an open source model that does pretty well at 32 billion scale. So today, how do we typically improve this type of like language model agents? So like what is a agent in essence? It's just like a language model, and that language model is able to generate action, and then that action get executed into some sort of like runtime, and then that turns into observation and then you feed that to the language model at the next turn. So I think most people are doing today is like we are, for example, designing better tools for the language model to use. For example, if it's a file editor, I should add enough reminder so that the agent knows how to properly use this file editor and avoid, for example, bad cases. As well as, for example, designing specialized workflow. For example, I want to solve GitHub issue really, really well. So I wrote like a 10-paragraph prompt about things you should do, things you should avoid, and do the prompting there so that the agent is like really excel at a certain task. But like, I think the downside there is like the amount of work only sort of like is only kind of gonna work on the domain you optimize for. It's hard to generalize across other domains. So in this work, we are actually trying to do something general. So we are actually trying to do learning and search by allowing agents to interact with the environment more and sort of like learning from those interactions. So what is SweetGym? So we build a SweetGym environment. So it consists of like 2.4K real-world tasks grounded in like GitHub code base. Basically, we crawl a bunch of GitHub issues. And then we actually configure those GitHub issues into executable environment where you can actually run those unit tests to provide as a signal of like whether the agent is doing well or not. So what we do is like we first collect the task by finding like top Python repository on GitHub. I think we initially searched for like 6K repos, and then it's basically and then finally we narrow down to 358 repos based on certain criteria like the repo needs to have like unit tests, and the repo have like at least 100 stars and have some metric that shows like this repo is have somewhat of like a good quality. And then the second thing we do, which is like, this is like the really hard thing to do, is like we set up those environments and validate the task. Basically, we configure like the environment for each of these repository so that you can actually run unit tests there. The challenging there is like a lot of environments use different like dependency managers. Some of them use pip, some of them use like poetry. It's right now this task kind of relies a lot on like a human effort. But like going forward, we are thinking about how we can automate this like environmental setup so we can get sort of like more of this type of environments. And then these are the distribution of the repository as well as like the statistical of data set. So for example, SweetBench have like 2.2K example where SweetGym have 2.4K. And then for average line of code is like about 340K to 360K. So they are about comparable. But like on the accuracy side, actually SweetGym, like GPT-4o's accuracy on SweetGym is actually much lower than the accuracy on SweetBench because we actually include a lot of like, in my opinion, it's like kind of harder repo like pandas, where you actually need to get some C file to compile before you're able to like reproduce the error and then actually running the test. And it's super like resource consuming. Yeah, and then eventually we get like 2.4K validated instance from 11 repo where we can run unit tests for each of them. And then how do we improve OpenHands with SweetGym? So what we are doing is like really simple. It's like rejection sampling fine tuning. So what we do is like we run OpenHand to solve GitHub issues in SweetGym. And then we basically train on those agent trajectories that eventually solve the task. Basically, each agent trajectory eventually leads to like a git diff patch. And then we simply apply that patch, run the unit test, and see if the unit test passed. If so, then we consider, okay, this is a good trajectory that agent should learn from. So we simply fine-tune the agent on that trajectory. So we actually see about 13% resolve rate improvement on the 32 billion model while we are working on this paper. So it's about training with like less than 500 trajectories we're having. So, and then I guess the next question go beyond this slide is like, does SweetGym scale with more compute? Can we get better by simply just getting more data? And the conclusion is kind of yes. So in this paper, we tried about like around 100 trajectory, 250 and about 500 trajectories. And you can see like this training time scaling. The curve is like sort of like log linear, where you just increase the trajectory, sort of like gives you better performance. And then what we found is like repeated sampling is highly effective. I assume until certain threshold. Basically, we don't have that computation budget to run through like 10K trajectory at the time. So I'd say it's like the size of SweetGym haven't been like, basically the SweetGym data haven't been like really saturated yet. So we can still get a lot of like improvement from like this benchmark, from this data set. And I guess then I'm going to switch gear a little bit. And the next thing I'm going to talk about is like how we do like inference time scaling for OpenHands agent. I know Graham and Robert mentioned about the critic model. So this is more about like the critic model itself. So outcome supervised reward model, this is sort of like a simple variant of the reward model. Simple variant of the critic model. What it does is like, given the issue description as well as the agent strategy, basically agent trying to perform some action, receive some observation, try to do stuff. And then you put both of these into the reward model, and reward model will predict the score. That score is trained to basically match whether the unit test actually passed for that given issue. So what it does is like, okay, you can imagine you have like a critic system where you can just feed what the agent is doing into it, and then it gives you probability of like whether the agent is actually solving the task. For example, a lot of time agent try to reproduce the error and then just stuck in infinite loop, trying to configure. I think in Sweetbench, the Django repo is like, you need to configure the setting before you can actually run those unit tests. So on those trajectories where the agent is actually looping, this reward model is supposed to give like a lower score. And then how we train it is like we use previously collected agent trajectory that we use to train the agent length model. And each trajectory is annotated with a reward where we get from like executing unit tests. But like unlike previously, we are doing like rejection sampling fine-tuning where we only train on the success trajectory. This time we actually train on both the success and failure trajectory, so that it's essentially like a classifier where you can classify whether like agent is going towards the right direction. Yeah, and then how are we going to use this sort of like critic model to actually improve the agent's capability? So the most simple baseline people are doing today is like called best of n selection. It's essentially you can run the agent on the same task, for example, for n times. And then you use the trained model to predict the reward for like each of those trajectories. Simply pick the trajectory that have like the highest score. And then you sort of like treat that as like your final solutions. And our experiment so far shows that if you sort of like scale the number of rollouts and apply the same verifier or the same reward model you train, you can sort of also get the log linear sort of like improvement curve there. So for example, if we are just running one rollout with temperature equals 0, you get like about 20%. But like if you just keep doing that for 16 rollouts, you suddenly get up to like 32%. And we are actually working on getting this integrated into OpenHands. Yeah, and then finally, we are going to release a language model tomorrow, I guess. It's like a v.0 research preview. So we train a 32 billion open source model, OpenHands LM v0.1 with SweetGene. So different from the model we train when we are doing SweetGene project, which like we only train the 32K model at that time. Like right now we have this model have like a 128K context window. And then based on evaluation, right now it gets about 37% verified resolve score on Sweetbench verified. So that's a pretty good improvement compared to like the 20% we were talking about earlier. And then the performance is kind of comparable with a model with like 20x more parameters, including the latest DeepSeek that released like I think the day before yesterday. I don't remember. So I think we will release the model weights tomorrow for download, and feel free to follow our Twitter for like more updates. And, yeah.
Yeah. So one thing that's been exciting is like ever since we started OpenHands, it's like an open source thing that you can run locally, and a lot of people were excited about this. This is the first time we really have like a model that somebody can actually run on their own computer, like on a single like 3090 GPU or something like this. So I think that's kind of an exciting thing. It works reasonably well. Didn't you use it to create a to-do list app or something like that?
Yeah, I tried that last night.
Yeah. The to-do list app is kind of like the hello world of code generation agents. So it passed the hello world at least. So yeah, we're kind of excited about that. Yeah, sure.
Are we running low on time?
Yeah.
I'll breeze through this.
Yeah.
All right. Before we go, I just wanted to talk through a few like tips for AI-driven development. You know, if you're using AI to lift your software engineering productivity, there's definitely it's a brave new world. There's lots of pitfalls, and I just wanted to talk through some best practices here. Number one, start small. I see a lot of folks as they try and use, especially agentic AI for the first time, they will pick a gigantic task, something that's like way too much for the agent to handle in one go. and then be really disappointed when the agent doesn't just one-shot it. I think starting with small tasks like fixing merge conflicts, fixing tests, and getting a feeling for the agent, what it does well, what it doesn't do well, you can kind of build up to bigger and bigger tasks where you might have to do a little more hand-holding. Giving super clear instructions to the agent about what it should and shouldn't be doing. The agents do very poorly with ambiguity. As we pointed out earlier, they will sometimes just plow through a task even if they didn't fully understand you. And then, I'm kind of shocked I have to say this, but always review the code. We've definitely talked to folks where they just, vibe coded their way through something and just kept iterating without doing any review, any like checking to see if the agent was doing stuff. The app was working, so they were like, that's fine. And then eventually it gets to a point where the code base just topples over under its own weight because the agent's been duplicating the same function 100 times and it gets hairy. So always same code review you would give to a human, if not more. Trust and ownership are super, super important when it comes to coding with AI. You need a human in the loop. You can't just have your agent pushing domain. As Graham pointed out earlier too, like in the early days of OpenHands, PRs would get opened like under the OpenHands account and nobody would own that change. And so now when somebody puts up a pull request, even if they're using OpenHands for it, their face is on that pull request. And so that means that they're responsible for getting it merged. If it breaks something, they're the ones that are going to be held accountable for that. They have to QA the change. They have to actually like run the app, make sure it works. So there's this old phrase, trust but verify. So, don't constantly feel skeptical of the AI, trust that it's going to do something right, but look at the code, run the app, make sure it actually all looks good before you actually merge it in. And then there's many different ways of actually working with these agents. There's, more tactical stuff like working inside your IDE or in a CLI where you're actively focused on a particular task. And you just want something to help you go faster. Stuff like Claude Code is great there. A lot of times we just want to work through like a web UI. Graham was talking a little bit earlier about being able to just like on his phone, kick off an OpenHand session and say like, please localize our app to Japanese. Super fun to just be able to pop open a web app and code that way. And then we're also integrating into third-party platforms. So I think increasingly you're going to see agents popping up in GitHub and Slack, being able to kick off sessions from inside of a pull request, or if you're having a Slack discussion about a particular bug, being able to kick off a task there. Super excited about all the different ways that we have of using these agents. I think this is still kind of like new. People are still figuring out how they want to best interact with software development agents. Cool. And then we want to end with an exciting announcement. OpenHands Cloud is now available to everyone. We're giving away $50 in free credits to all new users. You just have to come in, drop in a credit card, and you can use OpenHands for, depending on how big your tasks are, anywhere between like 20 cents and $20 is what we've seen. We do have much higher rate limits. One of our biggest complaints from users right now is that the basic Anthropic tier rate limits OpenHands so that it's kind of chugging along slowly. We have much higher rate limits thanks to our relationship with Anthropic, and our users can now take advantage of those rate limits. And because we have this server in the cloud, you can kick off conversations from the web, from a mobile device, from inside of GitHub. It's no longer a Docker container running on your laptop. So super excited about this. Check out app.allhands.dev. You can scan the QR code and get access. Cool. I think that's all we got. We have.
Yeah, thanks for listening, everyone. This was a long time in the making, so I think it's a pretty good experience now. If you were in the beta, sometimes the app fell over more than it should. It falls over a lot less now. But if you have feedback, we love to have feedback. We'll definitely want to have a discussion and questions and stuff. But one final thing is I'd like to thank our hosts at Databricks for hosting us here very much. And in particular, I'd like to thank Andy. I don't know if people know Andy, but he is hosting something called the K Prize, which is a kind of contest for web development agents on a unpolluted version of SweBench that all has to run with local open source models. And he also has an update about that, and we'd like to invite him up to do that before we
Is that your laptop you're presenting from?
This guy here.
Okay. Is it possible to?
Yeah. You want to pop open a tab?
Yeah, but I'm hoping.
Yeah, so while he's setting up, if there's any discussion, we can do that, and then when he's ready, yeah.
What's your preferred workflow with OpenHands? What's a day-to-day? Take me through a day in the life of using OpenHands as like an assistant to you, kind of?
Yeah, that's a great question. What's the preferred workflow for like a day of using OpenHands? So I can give it there's more usual things and less usual things. A more usual thing is we have a feature, like let's say we have a user complaining about something on our Slack. We send a message to the OpenHands Slack bot, and it will like open an issue on our repo.
Yeah, this one.
Yeah, like that down there. And it will open an issue on our repo. We don't usually immediately ask OpenHands to go and resolve it because there's an issue of like each person using OpenHands will get a whole bunch of open issues and a whole bunch of open PRs, and then you need to go in and resolve them. So usually we'll leave that until we have time to like actually work on it. Once we do that, we'll message OpenHands on GitHub, and it will like go in and start resolving that issue. If it's relatively simple, I'll just let it work. If it's not relatively simple, I'll click a link and go into the interface and watch it work and try to fix it if it's like going off the rails or something like that. I try to ask it to do test-driven development all the time because it works way better if you ask it to write tests first and then do the code until the tests work. And yeah, and then it'll send a PR. Sometimes the PR is all the time it's not. So I go in and like code review the code. And if I have the interface open, I'll just ask it to fix it in the interface and send a PR again. If I don't have the interface open, I'll leave a bunch of comments and then I'll add OpenHands on the PR and get it going and fix them. So yeah, and then yeah, it looks like we have the Zoom set up, so we'll do that in a moment. One fun one that I just did was I localized our entire app. So our app was like imperfectly localized. So I asked it to write a test that parsed the AST tree of like all of the JavaScript code that we had. I don't know how to write a JavaScript AST parser, but you know the language model does. And find all of the unlocalized strings and keep on running the tests until all of the unlocalized strings were localized. And you know that's the kind of thing you can do with an agent. That would be like extremely difficult to do, you know, without an agent. So, but yeah, anyway, turning it over to you.
Yeah, awesome. Thank you for that. They are also going to continue running meetups in SF. So if you have another space, I think we're going to be happy to continue hosting them here at Databricks. But if you have another space and you'd like to host them in a future meetup in a few months, feel free to approach them and let them know that. And in general, if you have a space, I also organize a bunch of different meetups. So happy to let you know. Please let me know, and I'll connect you with folks like Graham and others who are looking for the other side of the marketplace. All right, so great. I'm Andy Kowinski. I am a founder of Databricks and a founder of Perplexity and a founder of a new thing called Laud. And as part of the build up to this thing called Laud, which is it's a venture fund and an institute that supports researchers as a nonprofit for and by researchers themselves. That's what Laud is. And as a build up to this thing, Laud will be doing competition prizes like this as a matter of fact with, like philanthropic money. We ran this thing called the K Prize, are running and ran it, and I'll give you an update about that right now. So but it all starts with a love story. I looked at Sweetbench shortly after they published it, and I fell in love with it. And that's because it's very hard, or it was, and this is the life cycle of benchmarks. And we're going to do something about this never-ending hamster wheel that we all live on, where when I found Sweetbench, it was less than 5% state-of-the-art accuracy, or number one leader. Now, I think OpenAI's most recent thing on the non-verified was 70%. It's built from real-world data. You can say the SAT is also real-world data, but I think the fact that humans trying to solve an actual problem wrote their problem down in English or whatever language, and then the same or some other human came in and solved that problem. And the point of that problem was to like actually ease someone's pain or add a feature. That feels like a benchmark or a gold standard for real world. And I think that really inspired me. I thought it was genius for Carlos and John, the PhD students at Princeton who wrote this thing, who I got to know through this, to come up with the idea to go scrape it. And then they did. And then it measures something that I personally connect with. I think that software engineering is kind of one of the more meaningful types of technology development humanity has come up with in the last 30 to 50 years. You can debate with me whether we've moved humanity forward with it or backwards, but I personally think software engineering has moved humanity forward in terms of global prosperity and the sort of connectivity we can have. Obviously, it has its challenges, but that's my philosophy on why I love being a software engineer. And the AI paradigm that we're all in right now, and this specific meetup with this specific team of people moving the frontier the way they are, is testimony to that. So given that I loved it, I also decided that I should, continue to iterate and improve on it, because some of the things I observed about it is now it's not hard enough. Subbench verified was an expensive way to solve this. I came up with another expensive way to continue the path of solving this. Contamination is inevitable for something where you're copying from open source repositories, because the models, all large models are trained on the open source repository, the most popular open source repositories. So it again is another type of hamster wheel that we live with, and contamination is just tricky and nuanced, or basically inevitable. And I personally love open source, and so I wanted to continue to double down on incentivization mechanisms for people using open weight and open source models. I would love to have K-Prize restricted to open source only, actually, but we stuck with open weight for now. So I wanted a contamination-free leaderboard and wondered what it would look like if we restricted it to open weight only models, open weight and open source. So I had this idea that we should just build a competition around a contamination-free version of Subbench. And this thing called the K-Prize was born. I'm not going to walk through every element of this slide, but one of the more important things is you freeze and submissions and then wait. And this is how we achieve contamination-free. Kaggle has done this with other competitions for predicting the markets, where you essentially make people submit, have a cutoff time where you freeze their submission, and then collect new instances from the wild, and then test the submissions that were frozen on those new instances. If you want to keep running these competitions and have people get better and better, that means you need to have some life cycle of freeze, collect, publish the results, and then pipeline, hopefully, freeze, collect, publish the next wave of results, freeze, collect, publish the next wave of results. It's a very burdensome way to do this, but it's, I think, a brilliant way to do it, because until we invent time travel, it's provable that contamination was not at play with the results. And in fact, I would argue that we don't have any idea yet, until this is complete, what contamination's impact is on the Subbench results. Subbench verified can still have contamination because they're keeping it a secret which issues they scraped, but they are scraping issues that the models have probably trained on. And I love Subbench verified. So to make it real, in December, I went to NeurIPS and tweeted this on stage that I'll give $1 million for the first open source AI that gets 90% on contamination-free Subbench. And we assembled a team, 2 of which are here today, where Alex and Chris in the back somewhere, back there, and they helped me implement it. I mean, actually, they implemented it. And then I tweeted it, and we put this website up, and we made a cartoon version of myself, and it's been awesome. So 3 months went by, and I think a week or 2 ago, we froze submissions, so no more new submissions. And here are a few quick reflections on what we know so far, but we don't have results yet because we're still scraping. And you'll know in a minute when you'll know what the results are. First of all, it was pretty hard. And we don't actually know how hard it was, because what we did during the phase while you're submitting was put a leaderboard up that was just a secret set of issues that we scraped. So we kind of emulated Subbench verified. We weren't as diligent or vigilant with our verification mechanism as the folks who did Subbench verified. They had like a very rigorous set of verification with human software engineers. We had Alex back there and Claude do a bunch of verification for us, but not to the same level of rigor. That wasn't the point per se, but it is something we could talk a lot more about after after the talk here. And we'll get to how hard it was, but yeah, it was pretty hard. Just the peak at the, or kind of spoiler is the top result had about 10% of the instances solved of the leaderboard. The leaderboard had 70 some instances on it. And again, that's not a contamination-free data set. So we'll talk about that in a second. Here, breaking down exactly why it's hard, I've thought a little bit more about it even since I launched the thing. We require open models, so you can't use any of the GPT or Claudes. You have, because of Kaggle and our partnership, we partner with Kaggle. Thanks, Kaggle, very much. Kaggle provides free compute to contestants, and there's a global community, so they also provide a community that's enthusiastic about doing this, and this is a very lively community that participated with us. They did limit to kind of 4 L4s and some time limit on how long you can do this, so people had very tight compute constraints. So they had a model constraint, a compute constraint, a capability constraint, which is very fundamental, and this is one I lose sleep about, no internet. And the reason you can't have internet is because even though if you freeze submissions, but you allow them to use the internet 3 months later, it's going to allow them to have their agent consult something that might allow contamination to leak in. So that's a really hard problem to get around. If you have ideas for how to solve that, let me know, to allow internet access, but not allow for contamination that doesn't blow up 2 orders of magnitude or 3 orders of magnitude the expense of this thing, which is already very expensive, besides $1 million. And it's a contamination-free data set. Eventually, when we get to the actual results in a few more months, that alone should make it much harder. We don't know how much harder. Maybe much, much harder, maybe a little bit harder. It would be shocking if it didn't make it at all harder. So some results, 617 teams made at least one submission, 8,000 some submissions total. Here's some stats about the leaderboard. Again, 70 some instances on this leaderboard. They're secret, but they're not contamination-free. So that means that the submissions these people made were after these instances existed in the world. What they're ultimately going to get scored on in the end is on instances that were created after their submission. So hopefully they will perform less well once this thing is actually evaluated. But it seems to me that they're performing poorly enough already for my standards. 27 out of 71 issues were resolved. We feel pretty good about that, that because this isn't Subinch verified, the verification process is hard. And one thing that we would kind of feel anxiety about is people at the end saying, many of these aren't solvable. And that's a hard part of Subinch. If we talk to Carlos and John and the rest of Subinch folks, how do you make sure that instances are not over or under specified in the instance text versus the solution and the unit tests that test them? But at least we know that 38% of the secret test, not the final test, are solvable. And this solvable thing is, it could be that they're very hard. And so not one single instance solved it. So 38% is a bound, but not the actual number. It could be hopefully much higher than 30%. 38% are solvable. But it's not going to be 100% probably. The best submission out of all of them had 10 out of 71 correct. And 72% of submissions had 0 correct. We collected issues, and we are now scraping new issues from GitHub, which will again be, I think, kept secret. And we will announce the leader on June 11th after we're finished scraping and scoring, and then we'll be announcing. I don't expect, given these preliminary results, anybody to win the $1 million, which will require a 90% score on this new thing, given that the non-contamination free version is getting that relatively much lower score than 90% right now. And so I do want to give away the $1 million eventually to the person who gets 90%. If and when we can do that, maybe one of you, and maybe OpenHands. So we're going to figure out a way to keep this thing going. And I'll announce that later, because I want to give this money away. All right, that's it.
Any questions? I can get $1 million.
And we can switch back to Q&A for the OpenHands folks
Yeah,
too.
and maybe about either one of them. Thanks so much for this, and it was exciting to hear the results. I hadn't heard the results yet either, so.
Yeah, nobody had, even me, until earlier today, like an hour ago.
So this is our third announcement of the night. Great.
Okay, we got a question back.
So far, the OpenHands, the three bench, et cetera, relies on public GitHub repositories, which means the issues are usually skewed towards very open source type of work, which might be different than perhaps in-house development at startup instances. So based on your perhaps some internal bench, what type of task outside of the publicly available research benchmark does OpenHands do especially well, and what type of task does it do especially bad, poorly on? And how do you plan to, as an open source project going forward, to collect traces from the wild so you can get a better distribution of your task?
Yeah, that's a great question. So there's definitely a handful of tasks that the agent does incredibly well on. We're right now focusing mainly on like helping folks get pull requests merged. So there's a bunch of little bits of toil. So you can imagine like a very common developer flow. You pick up a ticket, you implement it, you think it's 100% of the way there, you put up a pull request, then you move on to the next ticket. And maybe a day or two later, you come back and you've got some comments from your coworkers. They're asking you to change the name of a variable. There's like a lint failure. There's a unit test failing. There's merge conflicts. It's basically like, a bunch of different little paper cuts that are preventing you from merging this PR. And those are things that a developer would see as like just toil. It's just like annoying. I have to context switch back to this whole thing. And it's stuff that the AI is really good at because it's just very rote. So like merge conflicts in particular, I've never seen OpenHands not do merge conflicts properly. So those tasks are the things that I love, just saying at OpenHands, just do this. I can stay focused on my current task and it can just take the PR over the line. So that's the easy stuff. The hard stuff is really where I would say when you need to do some like surgery on the code base. So like I had to implement a feature last week that seemed like on paper, it seems like a very straightforward feature you want to add. But it turned out that the way that we had architected things was maybe not set up nicely for things to happen this way. And so I was going to need to move a chunk of logic out of this class and into this class. And it was going to require some like open heart surgery on the database or on the application, on the code base. And that's the kind of thing where the large language model and the agent, it doesn't have enough context about the design decisions that went into the architecture over time. And so it took, like, I would say most engineers couldn't come in and make this change. It was somebody that like a core maintainer would need to come in and make this sort of change. And that's where the agent is just not going to help you unless you really guide it. And so what I did for that change is I went in and made some of the scaffolding of the change. I was like, we're going to move this here and this here. Now all the unit tests are failing, just go make the unit test pass. And it was able to kind of take what I did and iterate forward, but definitely required human intervention at the beginning.
Yeah, I have one comment too. So things that are really, I find that once you can write a test for something, it becomes like way easier. Once you can write a test to reproduce the failures. So like that's another thing that I'd like to improve our ability to do, like writing good tests to actually like localize issues. It's super easy to write a test that doesn't test anything meaningful at all. Like another thing that's tricky is basically debugging with multiple levels of indirection. So there's a bug that touches like 3 files. Like that's hard for human developers, but it's also really hard for agents. So yeah, those are some things that are a little bit harder. Going through the code base and like localizing the entire code base, the entire app, that's something that would be horrible for human developers, but it's like, once you can write a test to identify all the like unlocalized parts, it can just go through and plow through it and do, like modify 50 files and be fine. So yeah.
So the agentic coding space has gotten very saturated in the last year, and you guys now have a ton of competitors. I'm wondering how you see yourself differentiated going forward.
Yeah, I think one of the biggest things, and yeah, maybe Robert can comment about this as well, but I think one of the biggest things is we really want to be in the space where we're going to the places where you typically communicate about code. So for example, on GitHub, on Slack, and other things like this. And we want to be able to autonomously get you pretty far, ideally all the way to the finish line on any particular feature that you would want to create, and have like multiple agents working at once for you to solve these sorts of things. And then separately from that, like as Robert said at the beginning, we kind of like ideologically believe that open source is a good way to do this, and it's a good way for like developers to be able to participate in the process. And so we're also hoping that, you know, hopefully some of the people here like open source as well and would like to do that. But of course, that doesn't mean we get to slack off on being like the best possible option. So yeah, maybe those are the two biggest things.
Yeah. Yeah, I think open source is definitely a big piece of how we differentiate. But I think there's two main ways that I see the code gen market splitting. One is there's a lot of tools that are meant really for like product managers or designers or junior engineers to like get a prototype together really quick. We got like bolt.dev, Lovable, v0.dev, some really cool stuff happening there. I'm really excited for like, you know, my little brother to just be able to like throw in an idea for an app and like get something out the other end. And then at the other end of the spectrum, you have stuff that's meant for like senior developers who are working on production code that's going to go out to thousands or millions of users. And we're very much on that latter end. Like we're really focused on existing code bases, working on production grade code, not, you know, getting a quick prototype out. So that's one stake in the ground. And then the other way the market kind of splits is on the one hand, you have like very tactical tools like Cursor and Copilot, which are in your IDE and like you're zeroed in on a task and it's helping you just go faster. Cool stuff. I'm a big fan of Copilot. I use it every day. Although less and less as I switch to the more agentic side of the spectrum, where it's more about this asynchronous, like I'm going to describe the task that needs to be done, throw it off to the agent. It's going to go off and work for 5, 10, 15 minutes, maybe even longer. And then it'll come back to me when it's done and I'll help it go forward even more. And I can do multiple things at once and I don't have to be there with it, you know, focused in on a task. I find as I use OpenHands more and more, I'm not like squinting at my computer screen as much. I'm not like having to build up all this intense context about what's in which file and where. I just kind of have to have a vague sense of like, okay, what is my code base like? What is the change I want to make? And it's a much more kind of like relaxed process. And so we're very much at that agentic side of things. We don't want to be inside your IDE. We want to be, you know, more at that collaboration layer. We want to live in GitHub and Slack and Jira and kind of work with you. And I don't love the mental model of like it's just like a coworker, but that's kind of the interface that we want.
Thanks for presentation. I have another question. It's about currently there are so many agentic workflow. So I think different agents have different system prompt. I think system prompt seems to be the core part of the whole agents. So I wonder, as a user, what we can do over the like OpenHands? Do we need to modify the system prompt or not? Or we should, you know, fix the system prompt and do different application? Because as the professor mentioned before, that and the OpenHands can do a lot of tasks like coding tasks or other tasks. Is it means using the same system prompt can help us achieve the goal, or maybe different system prompt can help us to achieve better performance? Because I know currently the orchestration already fixed. I think like a Docker-based execution, and you build a very good you know, orchestration. So I wonder whether you encourage a user to like change your system prompt, or you think current system prompt is also good enough.
So yeah, our system prompt is actually very small, right? There's very little in there.
Yeah.
It's more about the tools that you give to the agent to do its job. And I would say in terms of what the users can do to really help guide the agent towards the kinds of things that they want it to do or the ways that they want it to behave, we have micro agents as basically a ways to inject more context into the agent, either every time it runs or just based on certain keywords or certain contexts, like if you're in a certain repo. And that's the best way. If the agent is like, you know, we basically built something that generalizes to everybody, but not everybody codes in the same way. So if you have specific tasks that you're working on over and over again, or you're working in a specific programming language, you can kind of extend the agent that way through micro agents. Did that answer your question?
You may extend to a micro agent. We don't need, we can keep the system prompt the same.
Correct,
Because,
yeah.
but I think recently you include like a thinking tool. So according to my observation, you just modify the system prompt and you just adding some new like prompts, new word to it. We need to to use the thinking tools. Then it modify the system prompt. So if we have other new tools, we want to let model to know what we should do. We need to modify the system prompt or just
Yeah, so I guess what we are trying to do on like the architecture design phase is like we want to keep the action space as simple as possible. So basically all you have is like a file editor, you have a terminal, you have a web browser. And maybe coming next, we have like a generalized interface to like MCP, for example. And that's sure like potentially that's all you need for doing everything. But like in terms of like, for example, you need specific tasks for a specific job. So I have an example. So while on my flight to here, to San Francisco, we have like a DL4 code workshop, like camera ready deadline. And then I need to shrink that switching paper into like from 10 pages to 9 pages. And then what that requires is like, you need to tell the agent how to basically compile a text file into PDF. And then how to essentially, for example, read that PDF into text. So that agent can just like modify the text file, recompile, see if it's go back to 9 pages or something. So you could do things in 2 ways. For example, first, you could write a tool that takes in the text file and then compile it into a PDF. And then expose that to the agent. And you add something in the system message. Whenever a user sends you a LaTeX file, you use this tool. But like the challenge there is like, as you want the agent to do more and more things, your tool set will just explode. You have a lot of tool sets. So what we're doing with micro agent here is like, okay, agent, you can use terminal, you can use file editor, you can use browser. So here's the thing, I have a micro agent called PDF LaTeX. So whenever user types in like keyword LaTeX, that micro agent gets activated, and that contains a protocol. You should like an apt get install like a text live base or something, and here's how you can install this base text. And then you can call this command to compile the things into a PDF. And then that thing, after you provide this type of specific instruction on specific type of problem you are interested in, agent generally works pretty well after that. So I imagine micro agent would be like our way of like trying to getting agent access to as much tool as possible without actually like putting a bunch of tools into its action space and making the agent like faster.
Yeah, and one final thing is it's all open source. So like if you want to go in and like modify the system prompt and make it work better, and then you demonstrate that it does, you can like either use that version or contribute it back or something like that. Like I don't think we're done engineering the system prompt. In fact, I know we're not done engineering the system prompt, and we may need to do other things. So it's just kind of we want to have a general agent that can do like many things. And like at the very beginning, we had a slide that was like, if I give you a terminal, I give you a file editor, I give you a web browser, you could build $1 trillion company, right? So the question is like, what sort of customization do you need on top of that? And the answer is you probably need knowledge, which is like we get through micro agents. Then do you need something else? Maybe you need something else, and then you can go in and engineer it yourself, or ask us and we can try to help engineer it or whatever. So yeah.
Back here. Right behind you, by the bar. Oh, also there.
Yeah, congrats on the announcement. I wanted to go back to the sort of, you mentioned the training on the trajectories and reward model for the OpenHands LM, but before it was introduced, were there any learnable components other than the base LM?
Are there learnable components other than the base LM? I think
before OpenHands LM.
There is the critic model for inference time scaling, and that's also learned. It's basically you feed in the OpenHands trajectory and you guess whether it's a good one or not. Yeah. So I think those are the two main components. Yeah.
Also, just I think Rob at some point mentioned kind of like moving away from the tactical view, right, from the editor to kind of more sort of decoupled way, right? But there is like an ecosystem of tools, and you just like pick off this section, you do this or that. Yeah. Do you foresee? Do you have like a vision for an agent that's kind of like proactive in the code base, that you don't have to give commands to, but maybe they'll, look at the code base and think, oh, that's the feature that you could need.
Yeah. One of my favorite stories from the community is we actually have a user who hooked up OpenHands to Datadog. And so anytime there's a 500 error that happens in the server, even if it happens at 2 in the morning, that kicks off an OpenHands session, and they wake up the next day to a PR that solves that 500 error. So super, super cool to see that kind of automated stuff. I do think there's a lot of room for automated code review. We've gotten a lot of requests for like, I never want people to use X library or something like that. Like they have sort of like internal policies that are hard to enforce in other ways. I would love to, I was thinking the other day to just have OpenHands just look at our code base and decide like, what needs to get refactored in here? Like, where's the spaghetti that we need to figure out?
I think even further, and also like take into account the MPC,
MCP, yeah.
I don't know much about it, but I'm assuming it's a sort of change of like the states or whatever.
It's like it's basically an API layer for the agent.
But I'm wondering if maybe to take this sort of proactive agent mode a step further, do you foresee coding without language at all?
Just vibe based, like literally just send it vibes. And no, I think it's there's definitely like I've also talked to folks who are interested in like just taking support requests and immediately like flowing that through to a pull request. And like I don't think we're at the point where you can just let it merge to main, but like maybe in 10 years, I mean, I'm making predictions. Time predictions in the AI field is notoriously bad, but maybe at some point we'll get the AIs just doing everything. There's no human in a loop anymore.
They don't need us to tell us to build it to do that.
Yeah, I think we're a very long way away from that, but it would be very cool.
Thanks for the presentation. So Meetup recently published a paper showing that when they evaluate the language models for agent tasks, they're becoming more and more efficient in longer running tasks, but still like they're if you just want to try once, they're not really good after like 10 minutes or like 15 minutes. The tasks that are taking like more than 10 minutes for humans. Are there any approaches that you have or any suggestions how can we prompt the LLM such that it can run longer tasks, it can break them? I asked a question in the Slack regarding like planning, which is some feature that Devin as a product is providing. So I wonder if you have any suggestions or anything planned for this.
Yeah, we're definitely working on planning. It's definitely on our roadmap. I would say breaking things down to having it run for more than 15 minutes or so on its own. It's I would say somewhere around like 15, 20 minutes seems to be a sweet spot. Beyond that, you just run the risk of it going off the rails. I think you kind of need to check in regularly because it gets a lot done in 15 minutes. It can rewrite your whole code base in 15 minutes, right? It's not like sending an engineer off for 15 minutes. It's like it sometimes gets like a day of work done in that 15-minute period. So yeah, I would say there's there might be a hard limit there that I think has more to do with the human agent interaction and less to do with the agent's actual ability.
One other comment is there's like a million workarounds to get things done without making something explicit. And like the workaround for planning is you ask it to write a README with a to-do list and then continue iterating until it's checked off all the things in the README. And that kind of works. Agents tend to like forget some of the things you told them to do. They'll like go off and do like some of them, but not all of them. So having like an explicit list that it can go back and reference and check, it can help with that too. But I think we want to like actually engineer that to be, a default workflow, like displayed in the UI and stuff like that eventually.
At 7:30, should we start to wrap up? Maybe one or two more questions.
Yeah, maybe let's finish up the last questions that anybody has, and then we can switch over to just talking or playing with OpenHands, and we can walk around and talk. Yeah, go for it.
According to what I understand so far, so all of your
all the training data are Python based, right? Most of them. And for the newly open source language model you guys are going to run is based on Python based repositories. So my question is, are all the results, are all the training results transferable to other languages like JavaScript, or newly released languages like Rust, or some legacy languages like Java? Sorry, I think this legacy language. Yeah, so I want to understand this. So does that for other languages? Because there are tons of code bases that are written in tons of open source projects written in other languages. Python is it's a large proportion, but not the complete, not completely all of it.
Yeah, it's a great question. I think language models tend to generalize some, but not perfectly. And like actually, Xingyao has a really funny like anecdote from the model that he just trained, which is if he trained it for one epoch, it's pretty good, pretty generalizable. If you say hi, how are you? It will say hi, how are you? If you train it for like 3 epochs, it will go and you say, hi, how are you? And it's like, let me examine the code base and fix the issue that you want fixed. So like, I think, you know, there are ways we can fix this and we want to fix this to make it general. So, you know, you have a diversity of training data and stuff like that. But, you know, that's something we're going to need to work on. In terms of whether it will generalize to other code bases, I think it's probably similar. You know, you train it for a certain amount of time, it learns how to use the tools, it learns general planning ability. But if you do it too long, it'll say, oh, you have a JavaScript app, let me re-implement that in Python or something. So, yeah.
Thanks so much.
Yeah. Okay. Yeah, thank you, everyone. And we're happy to chat. We'll be around for a while. Yeah, thanks.
Please take T-shirts. I don't want to take them all back to Boston. They're all over there, small to extra large. Yeah, and food, pizza, beer.
Drive home or walk home.
Yeah,
I believe we spoke on Discord because you guys were in the hackathon. So what I'm wondering, right? Because you guys do all this sophisticated data collection and training, and looking at the models, look at the inputs and outputs. What is your tooling for research? Right, like there's a bunch of this LM observability companies, all the way from Databricks, MLflow to like Lenfuse or whatever, Lenchannel, like what's your research tooling to support your type of work?
You should talk to him. He's in charge of our research tooling. We are using Lenfuse now.
Okay.
We use Light LLM just for like routing. We're starting to use not Diamond, I think, is a routing framework that we've been researching and evaluating. And like we're getting free GPUs from a bunch of different cloud providers.
Right.
But Xingyao can definitely go deep on the kind of like research stack.
Awesome.
Yeah.
Thank you.
Yeah. Thanks for coming.
Are you guys based in Boston?
I am, yeah.
Are you like hosting any events there?
I think that's probably our next meetup, yeah.
Yeah, because do you know Sunday Club by any chance?
Yeah, I do, yeah.
So that's friends of mine who started it.
Oh,
and,
very
like,
cool.
You know, they're working closely with like Lovable now, but I think like
Very cool.
connections, like things like this in Boston would be like so good.
Yeah.
I just moved out here.
Okay, cool, yeah. Do you want to put me in touch with those folks? I've never actually gotten connected with them.
Yeah, what's the best way to do that?
Do you want to just find me on LinkedIn? It's Robert Brennan.
What's the last name?
BRENNAN. First one.
There's a lot of awesome. Yeah, so I can connect with all of that.
Awesome.
I mean, it's grown to like 200 people now. It's crazy.
Yeah, no.
Like 70 plus every day.
They're doing really cool stuff.
One quick question on the tech features and the context population side, because it seems like LLMs often don't know like if they know something, or if they should like look for similar examples but not exactly related in the code base, versus like trying to go and search the web, and if you're searching the web, then you have all the versioning issues of passages. You guys have any tips on that?
No, honestly, I've been thinking about this a lot. Like I have to rely on my own intuition for what it probably knows and what it might be hallucinating.
You throw stuff at yourself mostly.
What's that?
So you throw in context like SDK docs. and
If
stuff.
if I've either seen it struggle with this SDK before, or I know it's too obscure for it, I will say go read the docs. Like I'm dealing with Keycloak as our authentication system, and it was trained on like V2 and we're on V3, and so it thinks it's using all the old APIs that are all deprecated. I have to just tell it like, so yeah, if I have any doubt, I say go read the docs before doing anything.
It'll do that just with the browser. Like
Exactly,
there's no
yeah.
other like LLMs like TXT auto generation type of stuff.
No, nothing like that. We have gotten better with we now have Brave Search, I think, integrated directly, so it can like get navigate the web a little bit more efficiently. But yeah, I think I would love to for the LLMs themselves to at least be able to introspect and say, do I know this, or like am I just hallucinating this random thing? Like, is this somewhere in my training set, or is this like some random new thing? Yeah.
Thank you so much for the event.
Yeah, thanks for being here.
Yeah.
Sounds good.
Nice to meet you.
Yeah, likewise. Thanks for coming.
I have like a serious question.
Yeah.
The open source philosophy.
Yeah.
Both in the model and actual, basically the app.
Yeah.
I thought about that a lot, but as a product standpoint, as a strategy,
Yeah.
you know, I've seen a lot of open source stuff.
Yeah.
And until this day, you know, it's hard to understand, you know,
Yeah.
lately why I think at this point you're more as a product guy. Let me
Sure. Yeah.
So like from the pitch and everything, I realize you're more of the product guy.
Yeah.
From a product standpoint, why you think okay, or when you said okay, this is something that should be open source, or this is something where this strategy could actually set you apart from competition, as you said. And it's because at the end I thought also like switching in the product because of whatever, I've realized that you will always live in the market. If there is demand for what you do, you will always be inside the market. And you will always have competition. And you will always have different strategies. And it's hard to see like the open source is a thing that really helps me a lot most of the time. You know what I mean? When you see that, when you think about that, because it requires more effort from some point of view. You know?
From some point of view, but also we get a lot of free development work, right? A lot of people are contributing and building for us and giving us feedback that otherwise wouldn't, which is super helpful.
But you could also, get in some like open roadmap or all this kind of stuff. You know what I mean? There are levels of open source, or levels of community building, or levels when you. So what clicks when you think, okay, I want to go full open source. Also with the new model that is better than DeepSeek and whatever, but it's open source. We sure will be open source.
I honestly, open source is just always one in the end with developer tooling. When you're selling to developers, like they trust open source a lot more. If there's an open source alternative, even if it's like 10% worse, they'll go with the open source because they know nobody can take it away from them. I've been working in open source for 10 years now. It's what I love doing. It's my ethos.
But this is an interesting insight. So you're also saying that if there is like an open source competitor, even if it's like 5% growth, they would prefer that.
Exactly.
Because the upside will always be 10%.
It's always free. Yeah. Exactly. So yeah, like every database now is open source. Every programming language is open source, right? I think developer tools should be open source.
So you okay, guys. So what you're saying is not like this is like a winning strategy, but it's more like a baseline that most product, let's say, development products have to follow for
A little bit, yeah, because somebody else will just come in and build it in open source.
This is probably a
thing.
real answer, you know,
Yeah,
because
yeah,
if I
yeah.
talk with someone like which is like open source enthusiast, will say, oh, because it's
Hey,
bad.
thanks for coming.
That was great.
Good to see you.
That was awesome.
Awesome, thanks.
I can't wait to
Bye.
get your slides.
Yeah.
It's like really, yeah, it really came together nice.
Thanks.
It was really cohesive.
Thanks.
Like it
Yeah.
was really good.
That deck has been evolving slowly over time. It's a little bit of a Franken deck, like we pasted the three together, but like
it's really,
I'm happy with it.
It was good.
Cool. I appreciate that.
So are you around tomorrow?
I'm here tomorrow, yeah. I won't be in the Menlo office, but I'm around San Francisco. Graham is has CMU stuff tomorrow. I think Xingyao and I are just working from hotel rooms.
Okay.
Yes, yeah, I'm gonna go to the anthology thing and then probably. Okay, cool, awesome. Sounds good.
This is an honest answer because if I talk with like an open source enthusiast or whatever, we will say, oh, it's better, the code is always better, the thing will, you know what I mean? They are really, you know, biased towards that.
Yeah.
What you're saying is that the way big companies also work nowadays and everything, you should, in your strategy, it's like having authentication, you know what I mean? It's like it's the baseline that you have to follow right now. For developers tools.
I mean, you don't have like Devon is an open source, right? They're doing Fine Cursor's not open source, so like you can start a good company, but there's an open source competitor at your heels always. And so it's
if you want to be like,
yeah, likewise. Thanks for coming by.
Yeah, cool.
Good luck with the startup. Hey, likewise. Thanks for coming.
I apologize already for harassing you. Probably the 100 person.
No, all good. That's what I'm here for, is to meet people in the community. Yeah.
I'm currently writing my master thesis at UC Berkeley.
Oh, cool.
And I already grammar.
Yeah, I love it.
Would you also like to do an interview within 15 minutes?
Sure, yeah, I'd be happy to do an interview. Yeah. You want to get me on LinkedIn?
Yeah, sure. Or we can also already schedule something.
I can send you my calendar. If you connect with me on LinkedIn, I'll send you a link to my calendar and you can get on there. Perfect.
That's the only drawback. Yeah, but it's also better at using it.
How about if the task is
how would you index like the
Do you index them with your name should become successful? Like you went to Columbia, then Google and so on.
I went to Columbia, then Google for about 3 years, and then I can't find my calendar. If you can send me a message, and I'll send you my calendar afterwards. I did a small startup that never took off. Then did another small startup that kind of took off and then kind of leveled off. But now I'm at OpenHands. Yeah. Just a lot of hacking, a lot of open source, a lot of just building and learning as I go. Yeah, I've had good points in my career and bad points. So it's always ups and downs.
How did you bounce back from
You just keep building stuff. Keep building stuff that you like. I just keep having fun with it. Like, as long as you're building stuff that you find fun and interesting and valuable, like that's all that really matters. And other people will come and find it, or they won't. You'll find a company to work for. I don't know. It's just kind of. I think the key is, if I had to go back and give myself advice, I'd just be like, just keep going forward. Don't get upset. Don't get, just keep doing what you're doing. And keep it fun. But it's definitely always ups and downs. Even I'm sure we're definitely on an upswing with All Hands right now. Maybe in 6 months, somebody else competes with us, or who knows what happens. We can't find funding. Who knows? So it's always always ups and downs. We're not actively looking for funding, but that's the next big milestone, is to raise a Series A. Yeah. Hopefully this year, maybe next year. Yeah, cool. Cool, very cool. Yeah, we have no shortage of VCs trying to get in touch with us, but we don't feel like we're in a place yet where we could raise money at a valuation that we would like. Yeah.
And also you use control if you do that.
It's better to have a really good story, and then you have to give up less control when you raise money, right? If we had our backs against the wall and like needed to raise money in the next month, or we're gonna have to fire everybody, then the VCs can just take control of the whole company, and that's not what we want. So raising money when we're in a good spot is much better. Yeah. So hopefully soon. Yeah. Thank you all for coming.
Yeah, it's great.
OpenHands has been like the best model on our internal benchmark. So we are working on automating machine learning engineering, applied machine learning engineering.
Cool, very cool.
Posted it in the OpenHands lab also. The idea is like there is a huge market for like getting these small pre-trained vision model of PyTorch, fine-tuning it on a specific task.
Yeah.
And you don't want to build a services company, right? You don't want to train ML engineer, right? So
yeah.
You can train an agent to like do this kind of task. That would be amazing. But when we compared like all of these other scaffolds like Git and simple React, OpenHands was relatively the best. But one area where everyone struggled was anything long horizon, right? So if you have to do like if you have to do even like a training for a few hours, it spits out tens of thousands of lines of logs. And then there is one place where it's like out of memory. OpenHands does a relatively better job, but even it misses sometimes. I'm curious to hear from you, like how do we solve this kind of task?
Yeah, I think that's a sort of like long tail task that like we I think we're going to need to. What we're finding more and more is like we've gotten a good handle on SweBench, right? Which are like all very like structured. They're Python problems that are like solvable in one ticket, right? And we're finding more and more like long tail cases of like, hours of machine learning logs coming out, or like there's all these like little edge cases that pop up as the number of use cases expands. And I think some of them have general solutions. Like, for that one, maybe we don't if we don't always stick all of the output into the context window, maybe we can truncate and let it search the output or something. But some of them just like, there's definitely been problems we've solved with just like a special case, one line of code for this particular weird edge case. So yeah, it's tough.
I'm guessing you are in Boston. Like we used to work from Boston.
Oh yeah? Cool.
It's based out of like Chestnut Hill.
Cool. Yeah. Nice. I used to live right by there. Very cool.
Hopefully, like things improve and if this long horizon thing works, that would be a huge thing.
I think we'll get there over time. But yeah, they definitely need a little bit more hand holding right now. Yeah. Cool.
So it sounds like you guys are going after the sort of professional software market.
Yeah, much more than like the
Not
low code,
the low code,
yeah,
no code.
Yeah. I find that like a more fun, more interesting, harder problem to solve. I think the other stuff is cool. I talked to Lovable in the early days, and I think they're doing really cool stuff. I'm definitely rooting for them. But it's a tricky audience, right? I think there's a lot of value in low code, no code if you get into like internal business applications, like companies that are just like, we need an app for our 50 truck drivers to be able to log whatever. I think there's a lot of value there, but there's also like a lot of people just kicking tires, building tic-tac-toe apps. That's a very fickle audience. It's hard people to like keep coming back and paying,
Sure.
So,
I think that what those tools don't do a great job of is like educating their users.
Yeah.
Like actually, if you are a non-technical person and you want to do this stuff, like probably you're missing some skills, right?
Yeah, exactly.
And so like the tool actually sort of needs like a theory of mind. Like, it needs to model your it needs to have like a skill tree.
Yeah, yeah, totally.
And so, you know, I don't know. I like Lovable. I think they're great, but I think that they're leaving a lot of value on the table.
Yeah,
a
yeah,
little bit.
interesting.
And so I've been thinking about trying to kind of essentially build like an OpenHands that like does try and kind of like model your knowledge of the process of building software essentially.
I would love something that helps like pull people into the software engineering world and be like, okay, we'll start by just giving you a little front end, and then like, you know, let's pull you into the CSS, and like, you know, you can learn how to modify the code a little bit and see what's going on under the hood.
Exactly. Yeah, you can kind of learn as you like learn about the plane as you fly it, as you know,
exactly.
whatever the metaphor is, right?
Yeah, take apart the plane as you fly it.
I mean, I think I'm trying to wrap my head around like, is OpenHands, the open source project, like a good chassis for
yeah, for sure.
Because like I essentially want to strip away a lot of the actual like good parts of it. In some sense, like I just want like a Claude artifacts type thing for the first 5 units, right? I don't want a terminal in there. That's like too much.
Exactly.
Really even need code, right?
Yeah.
Simple.
No, it's super modular. So you could rip away the whole UI. Like we have a headless experience for OpenHands, right? Where you can just script against this thing.
Okay.
You pass in a prompt. It'll just like chug along at a problem and come back with an answer without ever having a user interface. So you could basically use that. You could build a whole alternate user interface that just plugs into the same backend.
That's exactly what I want
like,
to do.
And like get it to just behave differently, and you know, extend the prompts in different ways so that there's like maybe a different system prompt or a micro agent that's modifying it. There's definitely we want it to be super modular so that like researchers who want to use it to like do weird new things with agents and solve a benchmark that we've never thought of before, we want them to be able to modify the system to do that. Some people end up forking the code base, but we want it to be so modular that you don't even need to like modify the code. You can just like use it as a library or things like that. So that's our hope, at least.
And if I want to do really dumb stuff, like I want to do a template. So like no matter what the user writes, we're gonna make like a shitty little React front end that uses these specific dependencies.
Totally, yeah.
Like I could do that today, essentially.
Yeah. I think you could just add a micro agent that specifically said these are the things you're gonna use. You're gonna use React. You're gonna use Redux. You're gonna no backend, no database.
And so then like I'm sort of putting guardrails around the whole prompting process, such that like whatever the user says, I can reasonably be sure that what's gonna pop out is like what I want in this particular unit.
Exactly. Yeah.
Okay.
Yeah. Very doable.
Today.
Yeah.
Oh,
yeah.
Excellent.
Yeah.
Okay, that's awesome. That's very exciting.
Yeah. No, I would love to see people building more interfaces to OpenHands, right? Like we've got the web UI, we've got a CLI, we've got a headless mode, we've got the GitHub and Slack integrations. But like I would love to see somebody build. Like one thing I do a lot with OpenHands is I build animated GIFs to like show mathy things. And there's like a lot of iteration where I'm like, okay, please make the circle red. And like I have a process now kind of set up where I can do that, and then like I can see the GIF update over here. But like it could really use its own UI, where I could do this a little bit more fluidly. I've kind of like hacked it together with the OpenHands UI. So I would love to see people build more like custom workflows, by just building front ends around OpenHands.
So there's one more piece that I think might be generalizable to general software development workflows that I'm thinking about, which is like, I want to make people clone apps.
Yeah.
So like learn to prompt by like, here's an example, because if you give them the spec, and the spec is essentially like solving a problem, right? Because the problem is, how do I describe what I want?
Yeah,
right?
exactly.
And so there's this idea of like this cloning exercise where like, well, I show you an app, and your task is to recreate that.
Yeah.
Okay.
You
Well,
can't screenshot it. You have to like.
maybe you could screen. I don't. Yeah. I mean, it is a part of vibe coding, whatever.
It's shocking how well they do. Just like you drop a screenshot in, and it's like
but for complex interactions, right?
Yeah.
For routing.
Yeah.
For state management, like all that kind of stuff.
Yeah.
If I want to be able to evaluate whether a user has successfully built those things, essentially I need a sophisticated QA agent.
Yeah, for sure.
Which
QA
is not too
so hard.
dissimilar from a QA agent that like normal software engineers might need if they want to check like, hey, we just deployed this thing to staging, like is it behaving the way we want it to behave, something like that. Like a sort of sophisticated like integration test.
Yeah.
have you guys thought about that at all? Like, is that on your radar?
I think that's going to be super important. The QA piece is probably like one of the biggest. That's the thing. That's the biggest like bottleneck in my process. Is I have OpenHands do something, and then I feel the need to download its changes, run the app locally, and like QA it, right? And like it has a web browser. We're adding the ability for it to click around the web browser and like actually use it the way a user would. But it's still, I wouldn't trust it to QA its own work. So if we could get a QA agent to like really like run through a script and make sure everything works properly, I think that could be really powerful.
Yes.
And are you all? I mean, are you all putting any like resources behind that, like in the short run, or is that with it?
Not currently. I would guess probably in the next 6 months that'll be gone. I think QA and code review are probably going to be two adjacent. Like these are things that you can't measure with. Right now, we're very optimized around SweetBench. Like, how do we just solve problems in a code base? QA and code review are two kind of like adjacent problems that aren't going to increase our SweetBench score that we do want to start dedicating resources towards. So we just hired a benchmark engineer to help us basically plot out that roadmap. So like if we decide we need to be good at X and that's not covered in SweetBench, he can build us a benchmark. Basically, the research team kind of needs a number to optimize. Like they need some number that they need to push up. And so we can build a benchmark for QA, and then the research team can just be like, okay, we got to push up the score by 5 points. That's the best way for us to iterate forward. So we're making plans there, but it's still more of a long play.
So you would build the eval first. You would resource the eval, and then the dev side would sort of follow.
Exactly. Yeah, because otherwise you don't know if you're really getting better or not, right? You can hack your way into having a QA agent and like gut check how well it works, but then if you make a change to the system prompts, you have to just kind of gut check it again, and maybe you're not checking the right kinds of tasks. And so having the benchmark makes a very clear line in the sand. This is what better means. This is what worse means.
That's very cool.
Can you use Open?
After you.
I was just going to ask, like, can you use OpenHands to create an evaluation benchmark? Like you have resolvers.
Oh, I mean, yeah,
some examples.
It's a big task, right? And there's a lot of like thought that goes into creating a benchmark that's going to measure the right thing, right? But you can definitely use OpenHands to like once you have like if you came up with the idea for SweetBench, you could definitely have OpenHands go out and be like, okay, find me the right pull requests to pull into the benchmark. Okay, scrape them. Or like Jing Yao was talking earlier, what they did for SweetGym is like they have all these hundreds of Python repos, and they needed to like learn to set each one up. One's using pip, one's using poetry, one's using this other thing. And so getting an agent to just do all that setup work to like basically set up the harness for the benchmark, very, very much a thing that an agent can do.
It's kind of like a data synthesis task almost.
Yeah.
So when you hire a benchmark engineer, what is a benchmark engineer?
That's not his title. His title's like researcher, but he's done a lot of work on benchmarks. He built one of the an agent that was at some point #1 on SweetBench.
Very cool.
And he's just very passionate about like how do you measure these things? How do you see if they're actually getting better or worse? How's it going? Devin, I'm Robert. Yeah. Thanks for coming. Yeah. Thank you. Yeah, it was fun to see how many people turned out. It was a really fun event. I'm here tomorrow, and then I leave on Friday morning. No, it's been a fun trip. Got to see the co-founders. Got to hang out here. I get to go to Anthropic tomorrow, which will be fun. I think there's a Manus event that I'm going to try and check out. They're definitely the hot new kids on the block. So,
do you have access to their like early release?
Xing Yao does. I've been playing with it on his computer. Xing Yao is friends with their CEO. Apparently, they took a lot of inspiration from our
That's what I heard.
architecture.
Someone was saying that earlier.
Yeah.
Apparently, the founder or someone in the C-suite was talking about how inspiring OpenHands was on Twitter.
Yeah. Apparently, their architecture is kind of like modeled after ours. We published a whole paper about our architecture. And like,
The Kodak.
The Kodak. So Xing Yao had the Kodak paper before we started the company, and then we published one on on just like the OpenHands architecture. And that, just kind of describes the event stream and the way we plug in the runtime and plug the agent into that. Yeah.
Do you think that the Manus in its current state could do some of these like complex QA workflows that we were just talking about?
Potentially, I haven't really explored the depths of what Manus is capable of, but it seems very capable. It seems very fast. Hypothetically, I think we can do all the same tasks. Like it has the same web browser, terminal, etc. But yeah, they seem very focused on generalist agent, right? Helping you book a flight, helping you plan a trip, helping you helping what an end user would do rather than coding tasks.
Consumer.
Yeah, which is I'm psyched for. There's so many little things that I do on the web that are just busy work that somebody could do for me.
Sure, I will get back to you later.
Yeah, great. Yeah, send me a message and we'll set some time up. Yeah, likewise.
We'll harass your last colleague.
Yeah, cool.
Yeah, great chatting. Nice to meet you.
Yeah, likewise. Likewise. Yeah, thanks for coming. I'm gonna grab a beer if you want to come on with me.
Yeah, thank you so much. Nice to meet you.
Can you raise our rate limits?
Yeah, I will talk to the PM.
Okay, we emailed, but we didn't get a response. Yeah.
Okay.
Could I forward that email? Yeah, actually.
Can you get mine too?
I'll do that now.
I think right now I do know the price.
The Flash model is pretty cool. It did quite well for a model that was actually.
Oh yeah, so that's the reason why we're tweaking that.
It's definitely it wasn't really
try to learn from
quantum
the
Jumping and going around and calling them. Yeah.
I think that's why we're using
trajectory of the source.
Other tasks. For data extraction.
Oh yeah, thank you for stopping by.
You've got a bunch of
Okay, great. Yeah, thanks for stopping by. See you later.
It's probably something API. Like I said,
Yeah, I like.
Where like years ago, I asked you, what do you think when hash gets language models as good as
yeah, so there's a lot of
I think you wanted something a specific and you thought that it's gonna take some time. You didn't give exact date, but you were not more that it's gonna happen in a year or two.
Yeah.